10.6, factoring a quadratic trinomial in the form of ax squared plus bx plus c, found in textbook pages 611 through 613. The objective is to factor and solve quadratic equations whose a value is not positive 1. We're going to talk about three methods, and the first one we call the AC method. So let's factor the following trinomial, negative 4x squared minus 6x plus 10. Notice that your a term does not have positive 1 as the coefficient. So we have to think about our binomial factors a lot harder. It's a lot harder to factor these. So using the AC method or any method, the first thing you always want to do is you look at every term in the whole trinomial and see if they share any common factors. If they do, you want to factor them out. And you never want to have a negative a term. So even if they didn't share a common factor, you would want to factor out a negative 1 and flip the signs on every term here so that your a term is not negative. So basically what we're doing is we're looking for anything we can pull out, and so you're using distributive property backwards. I'm going to definitely factor out a negative because I want to flip the sign on my a term. But then all of these terms are divisible by 2. So we're going to factor out a negative 2. Which would leave positive 2x squared, positive 3x, and negative 5. By factoring out the negative, we flip the sign on every term, and by factoring out the 2, we divide every single term by 2. Now if we distributed that back in, we would get the original trinomial. So now we know that negative 2 is a factor of this trinomial. We want to keep factoring this part of it until we have it in simplest factored form. So we want to get the two binomial factors that multiply to this quadratic trinomial. Since our a value is not positive 1, we're going to use the AC method. So the AC method is about looking at the factors that multiply to the a term and the factors that multiply to the c term and working with them until you get those factors to combine right to give you your b term. So you want to look at the a term, which is 2x squared, and you want to vertically write one of the combinations you could use to get 2x squared. We could go 2 times x times 1 times x. That's 2x squared. Now we want to look at our c term. Our c term is negative 5. 1 times 5 is 5. Now why do we look at a and c? Because in FOIL, your first terms give you your a term in the trinomial, and your last terms give you the c term. So we're looking at the factors of a and c. Now you want to make sure that they combine right to give you the right b term. So what you want to do is, I think I might have a binomial, 2x paired with 1 in the same binomial and 1x paired with 5, and we'll worry about the signs later. I know that the signs are going to be different because your c term is negative, and we're looking for factors of your inners and outers that will combine to positive 3 or have a difference of 3. To get your inners and outers, we can do our cross products here. 10x and 1x, do they have a difference of 3? They don't. They have a difference of 9. So we're going to play with our factors. You can just flip-flop 1 and 5 to 5 and 1 and recheck your cross products, because these cross products give us our inners and outers, and I'll show you that in a minute. So 2x and 5x do have a difference of 3x. So we know that we have 2x paired with 5 in a binomial and 1x paired with 1. Notice that 2x times 1 are your outers and 1x times 5 is your inners, and so that's why you want to cross check or do your cross products, because you can check your inners and outers that way. Now we got to think about our signs. We know one's positive, one's negative, and we want it to work so that they combine the inners and outers to positive 3x. So we want more positive. We want positive inners, that gives us positive 5x, and negative outers gives us negative 2x. Those combine to positive 3x. So the complete factoring of that trinomial up there is the negative 2 we pulled out to begin with, and then 2x plus 5 times the quantity x minus 1. There's my final answer. All right, let's look at another example using AC. Okay, so you definitely don't want this negative on your A term, so we're going to factor out the negative. But then looking across my terms, there's no other common factor, so just factor out the -1 and flip the signs on every term in the trinomial. Using the AC method, we're going to look at our A and our C and figure out how we can play with their factors so that they combine to get us this B term. So my A term is 15n squared. So if I list all the ways I could do 1n times 15n or 3n times 5n, you want to go with the central factors first and then work your way out to the extreme factors. So I would go with 3 times 5 instead of 1 times 15. So 3n times 5n. And then factors of 14 are 1 times 14 and 2 times 7. And again, you want to go with your central factor, so I would maybe go with 7 and 2 to begin with. And then if we can't find anything that works, play with the numbers and maybe switch. Okay, so we know that when C is positive, it means you have the same sign. And when B is positive, it means they're both positive. So we know it's going to be plus plus in our binomials. Let's check the cross products. Do we get a sum of 41n? 35n plus 6n is 41n. So I know I have this binomial factor, 3n plus 7, because they're both positive, and this binomial factor, 5n plus 2. And you can check it with FOIL. We also had this -1. If we FOIL this out, we would get 15n squared plus 35 plus 6 is plus 41n plus 14, and then if we distributed it in the negative, we would flip the signs to -15n squared, -41n, and -14. So here is my final answer. Don't forget the -1 we factored out in the beginning. And then the last example here, we're going to use the AC method on. Let's find the factors of 8x squared minus 34x plus 35. Nothing factors out, and A is positive. So starting with my AC method, we could go with 1x times 8x or 2x times 4x is probably a better, you want to start in the middle and work your way out. And then 1 times 35 or 5 times 7. They're same signs, they're both negative. So this is a little bit easier. I don't have to think about the signs. I know it's going to be minus minus. So now we're looking for the sum. We want our cross products to have a sum of 34. So 20x and 14x, there you go. We got 2x minus 5 and 4x minus 7. And then we can check it. 2x times 4x is 8x squared. Minus 20x minus 14x is -34x plus 35. I hadn't factored anything out in the beginning, so my final answer is the quantity 2x minus 5 times the quantity 4x minus 7. So that's your AC method. Now let's look at another method called splitting the middle. We're going to split the middle term, which is the B term, into 2 separate terms. These 2 terms need to be done in a way so that your 4 terms are proportional, and I'll kind of show you rather than explain it. It makes more sense when you see it. You know the first term is going to be 2x squared, and they're positive. You know the last term is positive 5. And what we're saying is that you're going to have 2x terms here. Something times x combined with something times x. You're basically going to split 11x into 2 ways. There's so many ways you could do it. You could go 5x and 6x, because that's 11x. You could do 20x minus 9x, because that's another way to say 11x. But you can't just do it any old way you want. They have to be proportional. 2 has to have a relationship with this digit, just like this digit has to have a relationship to 5. All right. So notice that in your pink terms, this is the first term, second term. This is the second term, this is the second term, second yellow term, second pink term. Since this is a positive, you want this one to be positive. Here's your first term in the pink, first term in the yellow. This is positive, you want that one to be positive because you want them to have the same proportional relationship. Now if I put in the numbers 10x and 1x, they combine to 11x. 2 is to 10, just like 1 is to 5. They both reduce to 1/5. They have a proportional relationship. So when you have it split so that you have a proportional relationship between these two numbers and these two numbers, you know you split it right. All right, so now what you want to do is you want to group them. You want to group the first two terms in a group and the second two terms. If there were a negative on this term, you'd want the negative to go in the group and put a plus between the groups. Since it's positive, you don't need to do that. You can just group the second two terms. Now what we're going to do is we're going to factor out common factors out of the first group. I can factor out using distributive property backwards 2 and x, which would leave x plus 5, because 2 times x is 2x squared, and 2x times 5 is 10x. Now let's go to the second group. I can't factor anything out of that second group. I just have x plus 5. And when there's no coefficient in front of a grouping, we know the coefficient is 1. Now we're going to make a really big group out of all of that mess. Notice that your binomial factor is identical. So before we go any further here, I want to remind you of a little thing we learned years ago. If you have 2 times 10 plus 2 times 5, both of these terms are multiplying by the factor 2. So we could use distributive property and distribute backwards and pull the 2 out, which would give us 2 times 10 plus 5. Well, both of them give us the same amount. This is 20 plus 10 is 30, and this is 2 times 15, which is 30. So when you have a common factor multiplying with another factor, multiple factors in a set, you can pull out the common factor using distributive property backwards. So what we're going to do is we have 2x multiplied by our binomial factor and positive 1 multiplied by that binomial factor. So we're going to pull the binomial factor out of this big set using distributive property backwards, and we get x plus 5, and what's left? If that's gone and that's gone, you're left with 2x and positive 1. And we just factored that using split the middle. Let's look at the next one. I can't factor anything out because they don't have any common factors. So I know my first term is going to be positive 4x squared. I know my last term is positive 35. Since this is the first term, this is going to be the first term of the second, so it's got to be positive just like this one's positive. Since this last term is positive, the last term of the first two has to be positive. So I can figure out that it's a positive and a positive. Now we want to split the middle term into two terms that proportionally work here with 4 and 35. If we split it, 20x's and 7x, they combine to 27x. And 4 is to 20, just like 7 is to 35. They're each 1/5. So that's proportional. That's the correct way to split that middle. So now we want to group the first two terms and the second two terms. Factoring out common factors in the first two, we can go 4x times the quantity x plus 5 plus, factoring out a 7 here, 7 times the quantity x plus 5. The fact that my binomial factor is identical, I know I did it right. So now we're going to make a huge group, and we are going to use distributive property backwards to pull out that common binomial factor, x plus 5, which leaves behind 4x plus 7. So factoring that trinomial, you would get the quantity 4x plus 7 times the quantity x plus 5. Let's look at the last one. Using again that split the middle, notice that every single term is divisible by 2. So if you don't factor out that 2, it's going to be harder. We're going to pull out 2. That leaves 2w's squared minus 7w's minus 15. Okay, now I know I don't want to lose that 2, so keep bringing him down. I'm going to split this middle term. I know that I'm going to get 2w squared, something times x, and negative 15. Remember, this is going to be the second term in the second set. So I want this second term in the first set to be negative as well. The first term in the first set is positive, so I want the first term in the second set to be positive as well. Okay, so I'm looking for negative x's combined with positive x's that are proportional and combine to negative 7w's. Let's go with negative 10x plus 3x. That gives us the negative w's. Negative 10w's combined with positive 3w's gives us negative 7w's. And then when we group the first two terms and the second two terms and factor out what they have in common, I get 2w's, w minus 5, plus 3 times w minus 5. Now we're going to factor out w minus 5, so you get w minus 5. What's left in here is 2w's plus 3, and then we had this other 2 we factored out in the beginning. So our final answer is 2 times the quantity 2w's plus 3 times the quantity w minus 5. All right, so that's splitting the middle. Let's look at the bottoms-up method. Okay, bottoms-up method only works if you factor out every common factor in all the terms and your a has to be positive. If you don't factor out all the common terms or you have a negative a value, bottoms-up will not work. You'll get the wrong answer. So always, always, always check to see what we can factor out. So I have to factor out the negative, but nothing else factors out. So factor out negative 1, we get 6y squared minus 29y minus 5. All right, now, we don't want to work with a trinomial whose a value is not positive 1. So what we can do with bottoms up is we can temporarily put the 6 factor into the c term, which means we're going to multiply it into the c term and rewrite it as y squared minus 29y, and then 6 times negative 5 is negative 30. But that's only a temporary fix to make it easy to factor this. Eventually later we have to divide out the 6. So you might want to note to self, later I have to divide by 6. All right, now we're going to factor this trinomial term like we normally would any trinomial with an a1 value. So y plus minus factors of 30 with the difference of 29 is 30 and 1, and we need more negatives. And now we've factored that trinomial. This is where we have to bring back the fact that we temporarily multiplied the 6 into our c term. How do we get our c term? It's our last times our last. Positive 1 times negative 30 is negative 30. So if we temporarily stuck it into the c term, then we can take it out by dividing those two last, because they create the c term, by 6. So now we're dividing the 6 back out. So now, if it doesn't divide in, you want a bottoms up. You don't want to leave a denominator. So you bring that 6 up to the coefficient of y, 6y plus 1. That's why we call this the bottoms up. And in the second one, if it goes in clean, divide it in. So those are my factors of the original trinomial. Now if we multiply it out to check it, and I'll only do it here on the first one, you'll notice we'll get that original. This would be negative 1 times 6y times y is 6y squared. 1y minus 30 is negative 29y minus 30. And then flip all the signs when you distribute in the negative 1, and you get negative 6y squared, positive 29y, and positive, oh, sorry, that's 5. 5. 1 times negative 5 is negative 5. So positive 5, and that's your original trinomial. All right, let's look at the next one using bottoms up. They don't have any common factors, 6, 19, and 15, and a is positive, so I can go ahead and start by temporarily sticking the 6 factor into my c term, which means I'm going to have to divide by 6 later. X squared minus 19x plus 90 factors x, x, same signs, both negative, 9 and 10, multiply to 90 and add up to 19, and now divide out that 6. You got to put this in simplest form. This is x minus 3 halves, because 9 and 6 reduced by 3, and x minus 5 thirds, because 10 and 6 reduced by 2. But this is bottoms up. You got a bottoms up. You can't have denominators in your factor, so we get 2x minus 3 times 3x minus 5. All right, looking at the last one using bottoms up. You gotta factor out that negative on your A term. Plus, they all divide by 2, so you have to factor out that 2. So we get 3x squared, negative 1x, and negative 4. Using bottoms up, later we're going to divide the 3 out of our last terms. So we're going to get negative 2 times x squared minus 1x minus 12. So that's x plus minus, because c is negative. Factors of 12 with a difference of 1 are 4 and 3. You need more negatives. And now you got to bring back that 3 and divide it out. So negative 2 times the quantity x plus 1, because it goes in clean. And bottoms up this one, 3x minus 4. All right, let's go ahead and factor using any method you choose. And I'm going to pull them up so you can see them all at the same time. And then when you're ready to check your work, hit play and we'll check your work. So let me just kind of scoot them up so you can see them all. Use whatever factor you prefer. And when you're ready to check, hit play. Okay, the first one, let's first factor out that negative, because you'd never want to have a negative on the A term. So 3x squared plus 4x, minus 4x, you got to flip the sign. Minus 4x minus 7. All right, let's use our AC method. So if we use AC, we know negative 1 is a factor. We'll figure out the other two binomials with AC. 3x and x. 7 and 1. We want to figure out if our cross products have a difference of 4. So 7 and 3 do have a difference of 4. So now we know it's 3x paired with 7 and x paired with 1, and we just got to figure out our signs. We need negative 7x's and positive 3x's to combine to negative 4x's. So using the AC method, those are the factors of that trinomial. On the next one, notice it's not in standard form. So you want to first use commutative property to get this in standard form. And then notice that your A term is negative. Factor out the negative 1 and flip the signs on every term. And then you really don't need any other method here because your A term is positive 1 once you factored out the negative 1. So y, same signs, both negative. 9 and 5 are factors of 45 that combine to 14. So that is the factors of the second one. Third one, you don't want to be moving into factoring until you factor out their common factor, which is 2. So 3x squared plus 11x plus 10. All right, now if we want to use bottoms up, we could do that. This is going to be 2 times x squared plus 11x plus 30, but we have to remember to divide off that 3 later. 2 times x plus 5 plus 6 and divide off the 3. So 2, bottoms up, 3x plus 5, that goes straight in, x plus 2. So those are the factors of the original trinomial. All right, so the whole purpose of learning how to factor is so that we can put quadratic equations in factored form and find their roots easier. So here we have an equation, and now we're not factoring, we're solving. So let's first get it into standard form by setting it equal to 0. So 0 is equal to 21n squared, positive 8n's, and negative 4. So there's multiple ways we could do this. We could use the AC method. Let's go with 7n times 3n for our A term, and 2 times 2. We're looking for difference of 8. So this is 6 and 14, so right off the bat we got it. And now we got to play with our signs. 7n is paired with 2, and 3n is paired with 2. And we know they're different signs. We need more positives. So we need our outers, the 14, to be positive and the inners to be negative. That gives us the -4 and the positive 8b term. We know that's equal to 0. Oops. So we just put it in factored form, set it equal to 0, and I'm solving. So now I use my factors and the zero products property to find the roots. N is 2/7, N is -2/3. Let's look at the next one. First, get it in standard form by setting it equal to 0. So 2x squared minus 9x minus 35 is 0. And then we can go ahead and use one of our factoring. Let's go bottoms up. We're going to divide off the 2 later. So x squared minus 9x minus 70 is 0. This would be x, different signs, plus minus. Factors of 70 that have a difference of 9, 14 times 5, and we need more negatives. But then we need to divide off that 2. So bottoms up, 2x plus 5, and x minus 7 equals 0. Now use zero products property. We're looking for the roots. So the roots are x is -5/2 and positive 7. Okay, let's look at the last one here. Get it in standard form. So add 2x and subtract 8 to get this side equal to 0. So 10x squared plus 3x minus 18. All right, now we're going to use one of our, we can use our AC method, do 5x and 3x. That's our A term. And then what, 3 times 6? We're looking for different signs, so a difference of 3. 9 and 30 do not have a difference of 3. So now let's do 6 and 3. 18 and 15 have a difference of 3. So I know that they're going to be the factors 5x paired with 6 and 3x paired with 3. One's going to be positive, one's going to be negative, and we need more positives. So our outers are 15, our inners are 18, so we need more positives, fewer negatives, and now we're going to find the roots. So using zero products property, x is equal to -6/5, or x is equal to, that would be add 3, divide by 3, positive 1. All right, let's look at a word problem. When a diver jumps from a ledge, his jump can be modeled by the vertical motion model. We know that height then is going to be equal to -16t squared plus initial velocity t plus initial height. Suppose the ledge is 48 feet above the ocean, and the initial upward velocity is 8 feet per second. How long will it take the diver to enter the water below? Well, when you enter the water, your height is 0 feet above the water. Initial velocity was upward, 8 feet per second. Initial height was 48. All right, so now we have this quadratic trinomial, and it's in the equation. Let's go ahead and, first of all, you don't want your A term negative, and you want to factor out any common factor, which would be -8. That would leave, what, positive 2t squared, -1t, and -6. All right, now if you want to continue to factor so you get this trinomial busted down to 2 binomial factors, using whatever method we prefer, we could do the AC method, 2t and 1t, and then 2 times 3 is 6. We're looking for different signs that have a difference of 1. 2 and 6 do not have a difference of 1. Play with your factors a little. 3 and 4 have a difference of 1. So I know I'm pairing 2t with 3 and 1t with 2, and you need more negatives. So these are 3t, these are 4t, so you need your 4t's to be negative, your 3t's to be positive, and now it's been factored with the AC method. So now I want to Find the roots because we're looking for solutions. Using zero products property, there's no root in the factor -8. It is a factor, but there's no root there because there's no t there. In this, we do have a t, so you set this equal to 0, and t could be -3/2. This one has a t, so there's a root there. Set that equal to 0, t could be 2. We're solving for time. You can't have a negative time, so the only answer that makes sense is 2 seconds. It takes you 2 seconds to hit the water.